Now the next topic is semaphores. We will see what kind of problem semaphore solves. We are discussing process synchronization in multiprocessor system. In last few videos, we discussed about critical section and the problems related to it. We have also seen how to avoid critical section problem. There are hardware and software solutions. We are talking about software solutions here. Why critical section is known as critical section? Because it is the section which is shared among multiple processes. It is a common part of a code. So, to avoid race condition or data inconsistency, we have to be very careful, and hence we should allow only one process to be in critical section at a particular time, and other processes should wait for their turn. We have discussed Peterson's solution. It satisfies all three criteria, that is mutual exclusion, progress and bounded wait. Peterson's solution works only for two processes, and we want the solution for n processes. So we will see whether semaphores can be used to solve this problem. Semaphores have three applications. It solves critical section problem for n processes. It decides order of execution among the processes, and it can be used as a resource manager. Okay, so here in this lecture we are going to talk about how semaphores are used to solve critical section problem for n processes. So what is semaphore? Semaphore is an integer variable, okay, and generally it is shown by variable s. Generally it is shown by variable s, but you can use any alphabet. But in literature, in books, everywhere you will find that S is used. Okay. When it is used to solve critical section problem for n processes, that time S is always initialized equal to 1. Once initialized, it can be accessed only through two atomic operations named as wait and signal. Okay, wait is an atomic operation. Wait is an atomic operation which decrement the value of s by 1, and signal is an atomic operation which increments the value of s by 1. Okay, now we'll see the structure of wait. So if wait is a function here, okay, wait is a function, in that you use a while loop, s is less than equal to 0 and s is equal to s minus 1. Okay, now why I have put why we have put the semicolon here. Okay, we have discussed this last video also. Okay, how while loop works generally. Okay, so this is a condition, and if it is true, it will go to the next statement, okay, and come back, and if it is false, it will exit the while loop. Okay, so this is the body of while loop. Okay, this is the body of the while loop. So here there is no body of while loop. We are directly going back to the condition. Okay, there is no statement here. Okay, so whenever this is true, this condition is true, it will keep executing this loop. Okay, it won't come out of the loop. Okay, so this is the structure of wait, and for signal, signal is just, there is no condition, it is just incrementing the value of s. Okay, now we'll see the working of these two functions. So you know this, we have seen entry section, then critical section. After critical section there is a exit section, and remainder section, then end of the loop. Okay, this we have seen earlier. So now instead of this entry section, we can have here wait and here signal. Now suppose for example we are taking number of processes P1, P2, P3 and so on. Okay. So okay. So now we'll decide, now we'll take, suppose P1 wants to enter a critical section. Okay, so S is equal to 1. So P1 will call this wait function. So what will happen here? The value of S is 1. So here this will be true or false. This will be false because the value of S is 1. So it will go to the next statement. So S becomes what? S value of S will be 0. Okay. And P will go to the P1 will go enter the critical section. It will start executing. Now at the same time, if context switching occurs, okay, context switching can occur at any time. So if the context switching occurs and the control goes to the next process P2, and P2 wants try to enter critical section. Okay, so again P2 will call this wait function, but what is the value of S that time? It is 0. So this condition will be true. If the condition is true, then it will keep continuing this loop. It cannot go out and decrement the value of S. So it will remain, it will wait here only. It cannot enter the critical section. So as soon as P1, okay, P1 finishes its job and come out and call this signal function. Okay, so signal function, this was the value of S is 0. So 0 plus 1 becomes 1 again. Okay, at that time P2 can enter the critical section. Okay, so here we have seen that the mutual exclusion is satisfied at a particular time. Only one process can be in critical section, another has to wait. And second is progress. So by default progress is achieved because the process who wants to enter this critical section should can set the value of S, can whenever it gets a value S is equal to 1 can enter the critical section. And the third criteria is bounded wait, which is not satisfied here, but it's not a mandatory criteria. So semaphore is still, it's a good solution for critical section problem for n processes.